Hello friends, in today's online class we shall study about one of the chapters in second year organic chemistry, haloalkanes and haloarenes. In our first year organic chemistry we have some idea about what alkanes are. So what alkanes are? Alkanes are saturated hydrocarbons which contain carbon to carbon single bond, and haloalkanes are derivatives of alkanes wherein one or more hydrogen atoms of alkanes are replaced by halogen atoms. Now if I write CH4, this stands for methane. From this alkane, if I replace one hydrogen by any halogen, say Cl or Br or I, then this becomes a haloalkane. So what haloalkanes are? Haloalkanes are organic compounds that are considered as derivatives of halogen derivatives of alkanes. Haloalkanes are the organic compounds in which one or more hydrogen atoms of alkanes are replaced by halogen atoms. Their general formula is Rx. So if R stands for alkyl group and X stands for halogen, then haloalkanes are commonly known as alkyl halides. More specifically, this becomes the general formula for MonoHaloalkane. Let us see how these are classified. Haloalkanes are classified into several types. The first is based on number of halogen atoms they contain. Based on the number of halogen atoms they contain. The first type is MonoHaloalkane. MonoHaloalkanes are the haloalkanes which contain only one halogen in them. If the general formula of alkane is CnH2n plus 2, then what could be the formula for MonoHaloalkane? CnH2n plus 1 X. Or in simpler words, this formula can also be given as Rx. For examples, CH3 Cl, CH3 CH2 Cl, CH3 CH, CH3 Br. All these are the examples of MonoHaloalkanes. So MonoHaloalkanes are those haloalkanes which contain only one halogen in them. In other words, MonoHaloalkanes are those alkanes wherein one hydrogen atom is replaced by one halogen atom. Then the second is dihaloalkane. A dihaloalkane is a haloalkane which contains two halogen atoms in them. In other words, they are prepared by replacing two hydrogen atoms of alkane by two halogen atoms. Examples: CH3 CH Cl Cl, or else CH3 CH2 CH Br Br. Both are dihaloalkanes. Then third is polyhaloalkanes. Polyhaloalkanes are the haloalkanes which contain more than two halogen atoms in them. This is first type of classification based on number of halogen atoms they contain. The second type is based on hybridization of carbon atom. Based on hybridization of carbon atom to which the halogen atom is attached. There are again different types. One type is allylic halides. We know that a single bonded carbon is sp3, double bonded carbon is sp2 hybridized, whereas a triple bonded carbon is sp hybridized. Now if a halogen is attached to carbon and if this carbon is sp3 hybridized and the carbon to which halogen is attached, if this carbon is attached to a sp2 carbon, then it is called allylic halide. More specifically, this example. In this example, halogen bromine is attached to a carbon whose hybridization is sp3, which is a single bonded carbon. If this carbon is attached to a double bonded carbon or sp2 hybridized carbon, then this compound is an example for allyl halides. So allyl halides are the organic compounds or are the haloalkanes in which halogen atom is attached to a sp3 hybridized carbon next to sp2 hybridized carbon, or else halogen is attached to single bonded carbon next to double bonded carbon. Then second is benzylic halides. Benzylic halides are those in which halogen is attached to a carbon which is attached to aromatic ring. Aromatic ring means benzene ring. Specifically, halogen is attached to a carbon attached to benzene ring. In terms of hybridization, you can define this as halogen is attached to a carbon which is sp3 hybridized, and this carbon should be attached to a sp2 hybridized carbon belonging to benzene ring or aromatic system. So what are vinylic halides? Vinylic halides are the haloalkanes in which halogen is attached to a sp3 hybridized carbon next to an aromatic ring. Halogen is attached to sp3 hybridized carbon next to a benzene ring. They are called benzylic halides. Then the third one, vinylic halides. Vinylic halides are those in which halogen is attached to a carbon which is sp2 hybridized. If a carbon needs to be sp2 hybridized, then it should have a double bond with it. Therefore, halogen is attached to a carbon which is double bonded carbon. The hybridization of this carbon is sp2. So if halogen is attached to a double bonded carbon, we say they are vinylic halides. Now the name of this example could be vinyl bromide. If it were Cl, then its name would have been vinyl chloride. Vinylic halides are those in which halogen is attached to a double bonded carbon. Vinylic halides are those in which halogen is attached to sp2 hybridized carbon. And the last one is aryl halides. Aryl halides are those in which halogen is attached to a carbon which is sp2 hybridized, as well as the carbon should be belonging to aromatic ring. In simpler words, a halogen attached to benzene ring directly can be an example of aryl halides. Understood? So let us revise the classification of haloalkanes. Haloalkanes are classified based on the number of halogen atoms into three types: MonoHaloalkanes, dihaloalkanes and polyhaloalkanes. Then based on the hybridization of carbon atom to which halogen is attached, they are again classified into four types. First was allylic halides, the second was benzylic halides, third vinylic halides, and fourth aryl halides. Allyl halide is the one in which halogen is attached to sp3 carbon next to a sp2 hybridized carbon, or else allyl halides are those in which halogen is attached to single bonded carbon next to a double bonded carbon. The second case, Benzylic halides are those in which halogen is attached to single bonded carbon next to benzene ring. In other words, halogen atom is attached to sp3 hybridized carbon next to sp2 hybridized carbon belonging to benzene ring. The third one, vinylic halides, wherein halogen is attached to double bonded carbon or else sp2 hybridized carbon. Fourth type, aryl halides, are those in which halogen is directly attached to benzene ring. Now because halogen directly attached to benzene ring can also be called as haloarenes, therefore these are separately studied and not mixed with haloalkanes. This forms the other part of the chapter. Now along with this classification, we also have further classification of monohaloalkanes. Let us see them. Monohaloalkanes are those in which one hydrogen atom of an alkane is replaced by one halogen atom. They are again classified based on the nature of carbon atom. Based on the nature of carbon atom to which halogen is attached. They are of three types. The first type is primary alkyl halides or primary monohaloalkanes. What are primary alkyl halides? A primary alkyl halide is the one in which halogen is attached to a primary carbon. What is a primary carbon? A primary carbon is the one which is not attached to any other carbon, or else a primary carbon is the one which can be attached to one more carbon. That's all. This means CH3Cl. In this example, Cl, halogen is attached to a carbon and this carbon is not attached to any other carbon. Therefore, this becomes primary carbon. In the second case, CH3, CH2, Cl. Here, halogen is attached to a carbon which is attached to only one carbon. Therefore, this is also a primary carbon. What is a primary carbon? A primary carbon is the one which is attached to no other carbon, which is single, or else which is attached to one more carbon. So, primary alkyl halides are those in which halogen is attached to a primary carbon. A primary carbon is the one which is not attached to any other carbon or which is attached to only one carbon. Then the second example. Second type is secondary alkyl halides. Secondary alkyl halides are those in which halogen is attached to a carbon. Halogen is attached to a carbon which is attached to two carbons. Secondary alkyl halides are those in which halogen is attached to a secondary carbon. What is a secondary carbon? A secondary carbon is the one which is attached to two carbons. Example, CH3, CH2, CH3. Of these, if I replace one hydrogen from the middle carbon by one halogen, then this becomes a secondary carbon. Why does it become secondary carbon? Because it is attached to two carbons on either sides. Can this be an example of secondary alkyl halide? Here halogen is attached to a carbon, this carbon is attached to two carbons. This is wrong. To whichever carbon halogen is attached, that carbon itself should be bonded with two carbons and not in the form of chain but instantly. If this were the case, okay, is this a secondary carbon? See, halogen is attached to a carbon and this carbon is immediately bonded to two carbons. Therefore, this becomes a secondary carbon. Understood? A secondary carbon is the one which is attached to two carbons. Then third, tertiary alkyl halides. What are tertiary alkyl halides? Tertiary alkyl halides are those in which halogen atom is attached to a tertiary carbon atom. Now, what is a tertiary carbon atom? A tertiary carbon atom is the one which is attached to three carbons. A tertiary carbon atom is the one which is attached to 3 carbons. For example, CH3, C, CH3, CH3, Br. In this case, halogen is attached to a carbon and this carbon is bonded with 3 carbons on all the sides. Therefore, this is an example for tertiary. Isn't it simple? A primary alkyl halide is the one in which halogen is attached to a carbon which is attached to no other carbon, or else halogen is attached to a carbon which is attached to only one carbon. A secondary alkyl halide is the one in which halogen is attached to a secondary carbon. A secondary carbon is the one which is attached to 2 carbons. A tertiary alkyl halide is the one in which halogen is attached to tertiary carbon. A tertiary carbon is the one which is attached to 3 carbons. In this way, monohaloalkanes are classified. Similarly, dihaloalkanes are also classified into 2 types. Let us see classification of dihaloalkanes. Dihaloalkanes are the organic compounds in which 2 hydrogen atoms of an alkane are replaced by 2 halogen atoms. Let us see how they are classified. They are classified on the basis of nature of carbon atom to which halogens are attached into 2 types. First type is geminal dihaloalkanes, or simply dihalides. Remember, they can also be called as dihalides. First is geminal dihalides and the second one is vicinal dihalides. What are geminal dihalides? Geminal dihalides are those dihaloalkanes which contain 2 halogen atoms. Say there are 2 carbon atoms and to which 2 halogen atoms are attached. The condition for a compound to be called as geminal is that the 2 halogen atoms should be attached to single carbon. In other words, they should be attached to same carbon atom. Can this be an example of geminal? It cannot be. It cannot be an example because the 2 halogen atoms are attached to different carbon atoms. If the 2 halogens are attached to only one carbon, only then they are called geminal dihalides. Geminal dihalides are also called gem dihalides. They are also called gem dihalides. Commonly, in common naming system, they are also called alkylidene dihalides. Alkylidene dihalides or simply alkylidene halides. Examples: CH3, CH, Cl, Cl. While numbering, you should remember that halogen should be given first preference. Therefore, it becomes 1,1-dichloroethane. If 2 same halogens are attached to single carbon, they are called geminal dihalides. Can this be a geminal dihalide? Say I will have 3 carbon atoms, out of which the middle carbon is attached with 2 halogens. Is this an example of geminal dihalide? Yes, it is, because 2 same halogens are attached to only one carbon. What are vicinal dihalides then? Vicinal dihalides are otherwise called Vic dihalides or Vis dihalides, or they are also called alkylene dihalides. We shall see more about geminal and vicinal dihalides common naming system in nomenclature. Now, what are vicinal dihalides? Vicinal dihalides are those in which 2 halogen atoms should be attached to different carbon atoms. Example: see these 3 examples. Out of these, identify which one is vicinal. Most of us confuse the definition of vicinal dihalides a lot. The reason is because while writing you are supposed to use the word adjacent. Vicinal dihalides definition is that there should be 2 halogen atoms, both should be same, and they should be attached to adjacent carbon atoms and not to different carbon atoms. So if you are writing vicinal dihalides are those dihaloalkanes in which two same halogens are attached to, in which two same halogen atoms are attached to different carbon atoms, that would give wrong information. Then what's the correct definition? Vicinal dihalides are those in which two same halogens are attached to adjacent carbon atoms or neighboring carbon atoms. So is this a vicinal dihalide? Here two halogen atoms are attached to adjacent carbon atoms. So it is vicinal. In this example, halogen is attached to first carbon, second carbon does not have any halogen, third carbon has. Means this is simply a dihaloalkane but not vicinal because it does not satisfy the adjacent carbon condition. So it is not a vicinal. The third one, here one carbon contains halogen, the next carbon contains halogen, third carbon does not contain. Means these two are adjacent carbon atoms and these two adjacent carbon atoms contain two halogens. Provided condition, they should be same. Both the halogens should be same. Means if this is Br, if this is Br, then it is vicinal. If one is Br and the other is Cl, they cannot be vicinal again. So vicinal dihalides are those in which two same halogens are attached to adjacent or neighboring carbon atoms. What if I say two same halogens are attached to different carbon atoms? Then it implies it is simply a dihaloalkane and not vicinal dihalide. A brief revision of dihaloalkanes. Dihaloalkanes are those organic compounds in which two hydrogen atoms of an alkane are replaced by two halogen atoms, preferably same halogen atoms. Based on the nature of carbon atom to which halogen is attached, dihaloalkanes are classified into two types, geminal and vicinal. Geminal dihalides are those in which two same halogen atoms are attached to single carbon atom or same carbon atom. Vicinal dihalides are those in which two same halogen atoms are attached to adjacent or neighboring carbon atoms and not different carbon atoms. That's all for this class. In the next session, we shall see their nomenclature and methods of preparation. Thank you.